section 7.1, polynomials. Before we get into polynomials, we need to discuss what's called a monomial, which is a number, variable, or product of a number and one or more variables with a whole number of exponents. Look, you've worked with monomials before. You've seen them in various formats, like the number -4. That's a monomial. It's a number by itself. It's all good. Another example would be 1/2 y squared. All of this is one term. It's one monomial because there's a multiplication here. And then we have the same thing for this one. We have 2.5x squared times y. All of this would be a monomial. Nothing really too complicated on that. A non-example would be x to the 1/2. We cannot have a fraction or a decimal in our exponent and call it a monomial. It just won't work because this gets kind of complicated. It's the same thing. If I have a -5 divided by x, this is not a monomial. And then if I have like the number 4 raised to the x power, again, this is not a monomial. Monomials are pretty straightforward. It's basically just multiplication of terms. 1/2 times y squared, 2.5x squared, y, and that's done. Then we have something that's called the degree. It says the sum of the exponents of the variables in a monomial. So if I gave you a monomial 2x to the 3rd power, we just look at this piece right here. This monomial has a degree of 3. It's just basically what the exponent number is. It has a degree of 3. Well, this one's a little bit different. It's 2x squared y to the 4th. Well, because we have two variables, we actually are going to add these exponents. And that means that this 2x squared y to the 4th has a degree of 6. All right, so it's just a matter of adding the exponents. The next piece that we have are what we call polynomials. It's a sum of monomials. And I'm going to put an S here. So this one right here, this 5x by itself, if I were to look at it by itself, 5x is a monomial. +2 is a monomial, but since I'm putting two different monomials together, I have a polynomial. To be more specific, since this one has two pieces, it's a binomial. And it's the same thing for this one. Each one of these monomials are different from another, and I have a polynomial. Multiple monomials here, therefore, be more specific, since it's 3 pieces, this is what we call a trinomial. And generally, these are the only major two terms that you call it. It's binomial, trinomial, and anything else, we just basically simply call it a polynomial. This brings us to what we call standard form. Is having all the monomials in a polynomial written from highest degree to lowest. So here we go. I've given you a little example. All of these are different degrees. So this is 2x squared plus 4x to the 3rd minus 2x plus 4. This is not in standard form, but this one is, and here's the reason why. This degree of this one is 3, where this one is a degree of 2. We need to have it in from highest to lowest. So I have a degree of 3, followed by a degree of 2, followed by a degree of 1, followed by a degree of nothing. All right, so this is literally from highest degree to lowest degree, and this is what we do for standard form. Being able to know how to write in standard form is going to save you a lot of trouble when we start to adding, subtracting, multiplying, dividing polynomials. Lastly, it's pretty simple. A degree of the polynomial is basically the greatest degree seen in the polynomial. So if I were to look at this particular polynomial, my highest degree is 3, which is this one right here. Well, that means that the degree of this entire polynomial is 3, and that's it. All right, so let's go ahead and hit some things. It says write the polynomial in standard form, identify the degree, and classify the polynomial by the number of terms. Well, this first one is easy. One, there's nothing else we can do with this. It's already in standard form because one reason it is a monomial, because it's by itself, there's nothing else with it, and it has a degree of 6. All right, done. This one right here, we have -2c to the 3rd power plus 1 minus 9c. Well, already you should notice that this is not in order from highest degree to lowest degree. So we need to rewrite it. So I'm going to write -2c to the 3rd, followed by my next degree would be 9c, because this has a degree of 1, then my plus 1. All right, so I have organized it from highest to lowest degree. On top of that, this is what we call a trinomial because it has 3 distinct pieces. And then lastly, the actual degree of this entire trinomial is going to be the highest degree, which in this case would be 3. So it has a degree of 3. All right. Why don't you take a look at numbers 3, 4, 5, and 6. Why don't you see if you can figure those out on your own? All right, number 3. This is a binomial, and there's nothing that we can do. It's already in standard form, and it has a degree of 5. Number 4, we can rearrange to have 3/4 m to the 8th plus 3/2 m to the 6th. This is a 2 term, so it's binomial, and its highest degree is 8. 5 is a monomial, and its degree is 4. 6, we can rearrange it to 3.2a to the 12th power minus a to the 9th power plus 18a. And since it only has 1, 2, 3 terms, it's a trinomial, and its highest degree happens to be 12. And that's pretty straightforward. All right, number 7 and 8, let's look at those. It's asking us to tell whether the expression is a polynomial. If so, identify the degree and classify the polynomial by the number of terms. All right, so right off the bat, if we look at this one, it says 2d to the 2.5. Stop. The answer to this is no. It is not a polynomial because of this. Remember what we stated at the very beginning of the video? A monomial, this right here, has to have an exponent that's to a whole number. It cannot be to a decimal. So this is not a polynomial. Looking at 8, notice that all the exponents are solid, so that's great. We also can say that this thing is not in standard form, and even though the question doesn't ask us, we can write it in standard form. So we would go negative 2u to the 10th power minus 2u squared minus 7u. So I've reorganized this. I also know that this is going to be a trinomial because it has 3 terms. And lastly, I know that the degree of this thing happens to be 10. I think we've answered all the questions. Pretty straightforward. All right, number 9, getting into something a little bit more tougher now. Number 9, you drop a ball off a skyscraper. Use the polynomial negative 16t squared plus v sub o t plus s sub o. Write the polynomial that represents the height of the ball, then find the height of the ball after the seconds. So basically, we're going to plug numbers in, all right? So, we know that v sub o, or v0, happens to be 0 feet, and we know that s of o happens to be 1,000 feet. So we're going to take these terms, I said 0 feet, that's 0 feet per second. We're going to take these terms and plug into there. So we're going to say negative 16t plus 0 times t plus 1,000. Well, let's simplify this. Negative 16t, that can stay like it is. 0t, well, that just goes away. And that leaves me with negative 16t plus 1,000. All right? Now, we have that. It's asking us to find the height of the ball after 5 seconds. That means that I can take this 5 and plug in the place of that t. So I can say negative 16 times 5 plus 1,000. And let's see what that is. So negative 16 times 5 gives me negative 80. Did I do... Sorry, I paused the video for just a second. I realized what I did because I knew that answer didn't look right. Go back and look at something. I'm actually thought about editing this out, but I'm not. I want you to see what I did. Notice the equation is negative 16t squared. That should be a t squared here. All right. So very important. I'm glad I called it. So I'm going to go back to this. I'm going to go actually, and 5 squared is 25, so we can say negative 16 times 25. This should give me a negative 400 plus 1,000. Figure that all the way out, And that ball that I've dropped is at 600 feet. So it's about somewhere around here, about 600 feet after the ball. And again, like I said, I'm glad I actually made that mistake on video because you can see what I did wrong. I forgot to put that degree of 2 in. All right, and that's it for this video. I will tell you this. This type of polynomial that you see right here, you're going to see a variance of this constantly throughout probably the next several months of your life. This is actually a formula that we use to define gravity and various other things. So just be aware that this is something that's going to be coming. You're going to see variations of this a lot over the next several months. All right, that's it for this video. See you in the next one. Bye-bye.